Yeah, 2018 12th question we have done. Now we should discuss 32nd question. 2018 32nd question. As shown in the figure, water is filled to the same height from level X. As shown in the figure, water is filled to the same height from the level X in three tanks A, B, and C, which are different in breadth. Which of the following is correct about the pressure PA, PB, PC? It's an easy question, right? We have studied, it's in theory, it's direct theory question. The pressure does not depend on the shape of the container. Pressure depends only on the height of the liquid. You can see here, the height is same from the X that they have marked. From the level X, the height is filled to the same height in the container A, container B, and container C. The height is same. You can see the height is same. What is the pressure at the level X? This is the level X, and you can see the height is same. Height is same. If height is same, this height, this height, all the height are same. If height is same, then the pressure at this point should be same. Therefore, PA is equal to PB is equal to PC. Therefore, a 32nd question, answer fourth. 32nd question, answer fourth. Now we look at 37th question. 37th question. This you have studied in history. This Pisokotue, Sluice Gate, Ralapanava, all these are in history. All these are in history regarding the tank structures. Tank structures. Now we will see the science behind the structure. Now this is what will happen. Now I will do only the important thing. They have asked now. Going to look. This is Sluice Gate. Sluice Gate. This is Bisakotue. This is Bisakotue. This is where water will flow. Now water will be like this. So what am I going to do now? I am going to open this sluice gate. I am going to lift this up. If I lift this up, what will happen? If I take this off, what will happen? If I lift this up, what will happen? Water will try to flow like this, right? Now, when I open this at once, water will flow with a very high velocity. Water will flow with a very high velocity. So, what is this Bisakotwana? When the water flows, once the gate is open, water will flow with high velocity. No? So, what will happen to this water? Water will rise into this Bisakotwana. Water will rise into this Bisakotwana. So, what will happen here? When water level rise into this Bisakotwana, the the velocity of water leaving out the sluice gate, the leaving out the sluice is less. Velocity reduces. So what is the use of this Visacotua? When the liquid flows with very high velocity, when water flows with very high velocity, the water will rise into this Visacotua, and therefore pressure at this point will increase. When pressure increases, velocity will reduce. And therefore, when velocity reduces, the water exiting the sluice will move with the lower velocity. There is a principle in physics when pressure increases, velocity reduces. Therefore, when this height of the liquid column in the Biscoff increases, you know pressure is equal. Now let me take this as PA, this as point A, and pressure here as PA. PA is equal to H rho G naught. Now let me take this as H high. Let me take this height as H. Okay, so when H increases, pressure increases. When pressure increases, velocity reduces. When pressure increases, velocity reduces. When the velocity reduces, the water will exit the sluice. Water will exit the sluice with a lower velocity. So in that question, what are they asking? The diagram illustrates a cross-section across the bund close to the sluice of a well. What is the structure constructed to reduce the speed of water flow by reducing the pressure when water is released from the tank? Therefore, answer should be what is the Biscoff? The sluice is the one which is helping. But the Biscoff is the one which is helping. Therefore, answer should be C. That is answer number 3. For 37, answer number 3. So 32 done, 37th done, 2018 done. Now we'll move to 2019. 2019. 2019. Question number 2019. 23, 32, 37. 23, 32, 37. The atmospheric pressure at the sea level is 1 into 10 to the power 5 Newton meter minus 2. The area of the tympanic membrane of a man is about 5 into 10 to the power minus 5 meters square. What is the force exerted by the atmospheric pressure on the tympanic membrane? Now, what is this tympanic membrane? Now, if I take this ear, this how the structure will be. If you need to know the exact structure, Google it and see. Okay. Now, this is a membrane. Membrane means like a thin structure. A thin structure. Okay. A thin skin is present. Thin skin is present. This is the tympanic membrane. This is the ear that we are in the outside. That is pinna. We say pinna. This is the outer ear. Pinna. So there is a hole inside in the ear. So when there is high pressure, when there is high pressure in the atmosphere, when there is pressure, what will happen? There will be vibration. Particle will be vibrating. Particles in the atmosphere will be vibrating, and therefore The vibration will be transmitted through this. This is known as, I forgot the name. What's it? Yeah, I forgot the name. It's a tube. It's a tube. This is the tube. This is the hole that we have in our ear. This is the hole. Here is the tube. And this tube is connected to a membrane. So what will happen? Yeah, this pressure will be transmitted through this tube now. So let me draw this membrane. Yeah, let me draw this membrane. This is how the membrane looks like. This is how it looks like. Here there will be membrane. Now let me draw it like this. It will be like this. So the pressure will be acting like this. Pressure. There will be pressure. Due to atmosphere, there will be a pressure. Once this part is exposed to the atmosphere, because this part is exposed to the atmosphere, there will be atmospheric pressure acting. Let me take this as PATM. Have they given their area? Yeah, the area of the tympanic membrane. This area is 5 into 10 to the power minus 5. 5 into 10 to the power minus 5 meter square. So what is this pressure? PATM. That is 10 to the power 5 Newton meter minus 2. So what is the, pressure is equal to force of area. Force is equal to pressure into area. What is pressure? Pressure is 10 to the power 5 Newton meter minus 2. And what is the area? 5 into 10 to the power minus 2 meter square. Meter squared, meter minus 2 will cancel off. So 10 to the power 5. Now 1 into 5. Now here it's like this now. 1 into 10 to the power 5 into 5 into 10 to the power minus 2. No? So 1 into 5 is 5. The next part is mathematics. In indices, you have studied, right? Now, indices, what you study? A square into B square. Now A to the power 2 into A to the power 3. So in indices, you have to study. If the bases are same, A is equal to 2 plus 3. That is, A is equal to 5. No? Likewise, 1 into 5 is 5. And then 10 to the power, like this. I'm going to clean this. Force is equal to P into area. P is equal to 10 to the power 5 Newton meter minus 2. Area is equal to 5 into 10 to the power minus 5. Yeah, not minus 2, minus 5. Yes, minus 5. 5 into 10 to the power 5 minus square, meter square. Meter square, meter minus 2 will cancel off. 1 into 10 to the power 5 into 5 into 10 to the power minus 5. No. 1 into 5 is 5. So A to the power x into B to the power y. Sorry, A to the power y is equal to A to the power x plus y. This is a note. 5 is 5 into, now 10 is the same. No? Now let me write like this. 10 to the power 5 into 10 to the power minus 5. So 5 into 10 is same in both. No? Base is same. So 10 to the power 5 minus 5. That is 5 into 10 to the power 5 minus 5 is 0. What is 10 to the power 0? That is 1, right? 5 into 1, that is 5 Newton. Anything to the power 0. A to the power 0 is equal to 1. 1000 to the power 0 is equal to 1. Anything to the power 0 is 1. No. 10 to the power 0 is 1. 5 into 1 is 5. 5 Newton. So answer should be 5 Newton. What's the choice? Choice number 1, 2023. 2019, 23rd question, choice number 3. I'm going to clean this. If you need anything, note it down. Pause the video and note it down. Now it is done. Now we are going to 32nd question. 2019, 32nd question. There is a greater chance for a man swimming in the water with a gas bubble at the base of a waterfall to drown. What is the reason for this? Now, in waterfall, you have seen this. Now here we have the rock. These are rock. The water is falling down from here, and this is the water surface. So, when this waterfall. So, when this water hits the surface, what will happen? Air bubbles will be formed, right? There will be large number of air bubbles will be formed. Now, some people they say, don't go near to this waterfall, right? Near to the place where the water falls on the surface of the water. Now, a waterfall, the water will be falling on a particular surface. No, on the base of this waterfall, water will be falling. Therefore, some the old people will say, don't go near to this point. Why is that? Because they will drown at this point. In this point, they won't drown easily. But at this point, what will happen? They will easily be drawn into the water. What is the reason? When water falls from a very large height, what will happen? Large number of air bubbles will be formed here. Large number of air bubbles will be formed. So, what will happen here? You know, density is equal to mass over volume. So, what will happen here? Actually, it's not this. When large number of air bubbles formed, when air bubbles formed, when air bubbles increases, what will happen? Density at that area, density in this area will reduce. What will happen when air bubbles form? Density in this area will reduce. Now let me take density at this point as D1 and density at this point as D2. Density at this point as D2. I can say that D1 is greater than D2. That is D2 is less than D1. So you know the equation upthrust is equal to, now when a man is swimming, what is the force acting on that person? That is weight W will be acting, and when he is underwater, upthrust force will be acting. Okay, what is the equation for this upthrust? Upthrust is equal to V rho G, right? Upthrust is equal to V rho G. So when the density at this point reduces, what is happening here? The density reduces, upward force will reduce. What will happen? If the upward force reduces, if the upward force reduces, if no one is pushing him up, if the force pushing him up reduces, if the force pushing him up reduces, what will this person do? The person will drown. He will drown into the water. That is the reason. When air bubbles formed, what will happen? Density reduces. When density reduces, according to equation, upthrust is equal to V rho g. When density reduces, upthrust will reduce. When upthrust reduces, upward force will reduce. When upward force reduces, this person will drown down. This is what it is. This is what is happening. Okay, now we'll see the choices. 32nd one. Increase in the upthrust exerted by the water. No, no. Thrust reduces, no. First choice. It's wrong. They say upthrust increases. No. Upthrust reduces. Upthrust reduces. Hmm. Decrease in the upthrust exerted by water. Yeah. Second one is correct. Now we see third one and fourth one. Dissolving of greater amount of gas in water. No. Decrease in the temperature of water. Decrease in the temperature of water. No, there is nothing connected with this temperature. Is wrong. This is wrong. So answer is second. For 32nd, answer number 2. Now we'll see the 37th question. I'm going to clean this. If you want anything, pause and note it down. Thirty-seventh question. Which following factor affects the pressure exerted by water on the bottom of a vessel filled with water to a certain height? This is the third time we are doing the pressure depends on height. That point you see the how much importance is that point. Now from 2014 to 2019, 5 US past papers. In this 5 US past papers, they have asked 3 questions under that point. Pressure at same height is equal. Pressure depends only on the height, not on the shape of the container. So that they have said, there is a vessel, it is filled with water. What is the pressure at the bottom of the container? That is, what factors depend on the pressure on the bottom of the container? What factors depend on the pressure at the bottom of the container that is filled with a liquid? A water, what did I say? Water or liquid? The thing is filled with water to a certain height. Volume of water, no. Shape of water, shape of the vessel, no. Area of the bottom of the vessel, no. Vertical height of the water column, yes. 37th one, answer 4th. But you see the volume of water, no. Shape of the vessel, no. Area of the bottom of the vessel. You know, pressure is equal to force or area, no. So at this point, the pressure depends on height, no. But the force depends on the area. Pressure doesn't depend on the area, but you know, force is equal to pressure into area, no. So this force depends on the area. If area changes, force will change. If area increases, force will increase. If area reduces, force will reduce. Pressure doesn't depend on the area, but the force will depend on the area. Pressure doesn't depend on the area. Pressure depends only on the height of the water filled in the vessel, but the force depends on the area. Okay. Therefore, 37th answer 4th. That's it. 2019 done. Now we are moving to 2020. 2019 done. Moving to 2020. 2020. I'm going to clean this. Any important points, you can note it down. 2020. 27th question. The 27th question, 2020. The maximum upthrust exerted by water on a certain object is less than the weight of the object. Then the object will, I have given it in the short note. Check it. Upthrust exerted by water on a certain object is less than the weight of the object. Upthrust is less. It means weight is more. When weight more, float on the water surface. No. Float partly immersed in water. No. Float fully immersed in water. Sink fully in water. What should be the choice? Choice is answer number 4. I have given you in the short note the 3 instances. It is filled to this height. And there was something here. There was a one here. And there was a one here. Object at this position, object at this position, object at this position. If the object is at this position, now you know for this object, there will be an upthrust U1. Let me take this as U1. There will be an upthrust. Let me name this as U1. And there will be weight W. For this also, the weight will remain the same. No? Weight will be the same. Weight of the object. Weight and upthrust U2. And let me take the upthrust U3, weight W. Okay. Here you see why the object is floating on the surface, being partly submerged in water. Is partly submerged, not fully submerged in water, partly submerged and float in the object, partly submerged and float on the surface of water. It means U1 is equal to W. While the object is not sinking down, the upward force is greater than the downward force W. U1 greater than W. That is why the object is at a higher level. Object is at high level. It means it is partly submerged and floating. Here you see the object is fully submerged. The object is fully inside the water. It is fully submerged. And yeah, it is fully submerged. If the object is fully submerged and floating, what will happen? What is that? That is U2 is equal to W. This is when U1 is greater than W. U2 is equal to W at this instance. And at this instance, what will happen? The downward force. Why the object has reached the bottom of the container? Because the downward force is greater than the upward force of thrust. W is greater than the upthrust. Downward force greater than the upward force. Therefore, object will reach the bottom of the container. Therefore, here U2 is greater than, sorry, W is greater than U3. Note it down. This important point. No. And also let me give you another special point. Now, yeah, let me take density of water as rho W. Now this is water, rho W. And this is an object no. This is an object no. Let me take this density as rho O. Rho naught is rho W. Density of water is rho W. Density of object is rho naught. Okay. Then mark this point. This is a special point. What is the special point? When the object an object fully submerged and floating, density of water is equal to density of object. That is, now let me write this like this. Density of liquid equal to density of object. Density of liquid equal to density of object. Mark this point. There can be this type of questions in the MCQ. Mark it. When object is fully submerged and floats, when the object is fully submerged and floating, density of liquid is equal to density of object. In this instance, density of object is rho naught. No? So rho naught. Density of liquid is rho W is equal to rho naught. Not this. Therefore, 2020 27th answer 4. Answer 4th. 2029 or 2021. 2021 28th question. I'm going to clean this. I'm going to clean this. Pause and note it down. No time. That's what I'm rushing. 2021 28th question. Which of the following phenomena cannot be explained by the Archimedes principle? A ship cruising in the sea, sinking more when entering a river. A balloon filled with helium gas moving upward through air. Balloon filled with helium gas moving upward through air. Floating of sunk orange seeds in a glass of orange juice when dissolving sugar. Lifting a large lifting a large mass by hydraulic jack by applying a small force. You can directly come to the answer fourth. Okay, that is Pascal's principle. Now see the 28th one and fourth one. Lifting a larger mass when hydraulic jack by applying a smaller force. This is not Archimedes' principle. This is Pascal's principle. Here I have a piston. I am applying. I have a smaller piston. I have a larger piston. And then there is a car over here. So I am going to apply a force F1. Here a force F2 is going to act. Let me take the area as A1. Here let me take area as A2. Here let me take pressure as P1. Here let me take pressure as P2. Now what is this Pascal's principle? What does he say? The pressure at this point, the pressure will be flowing through the fluid. Now here there will be fluid now. The pressure that is exerted at this point will move through the fluid, and then here the pressure will be acted like this. Here pressure will be acting on a large area. So as I said you earlier, you know pressure is equal to force over area. So force is equal to pressure into area. You know pressure here and pressure here same. No? The pressure that I'm exerting here will move through the fluid, and the pressure will be exerting like this. Therefore, pressure is same. No? Pressure is same in both the instance. So pressure is a constant. No, pressure is a constant. No, in both the instance. If pressure is a constant, then force is directly proportional to area. If I increase the area by 2 times, then the force will increase by 2 times. If I increase the area by 5 times, force will increase by 5 times. I said you earlier, no? Pressure will not depend on the area, but the force will depend on the area. How it depends on? Force is directly proportional to area. Force is directly proportional to area here. Force is directly proportional to area. You see, this is Pascal's principle. This doesn't depend on the Archimedes principle. What does this Archimedes says? The upthrust acting on an object when an object is fully or partly submerged in the water, the upthrust acting on the object is equal to weight of the displaced volume, weight of the displaced fluid. Sorry, weight of the displaced fluid. That is what is Archimedes principle. Therefore, what should be the answer? Let me check the other one. So I don't have any space, so I'm going to clean this. If anything important, note it down. Pause the video, write it down. Now we'll see the first one. What does this say? Ship cruising in the sea, sinking more when entering a river. That is because of the density difference. You know, seawater. Now, let me take density of pure water as rho, okay? And if anything is added to water, if anything is added to water, it can be salt, it can be sugar, any miscible component. If any miscible component with the water is added to the water, always the density of water will increase. Now density of pure water is rho. No? Now I have a water. Yeah, let me take density of pure water as rho. Now what am I going to do? To this I am going to add sugar. and I'm going to stir it continuously. After it stirs, what will happen? A clear solution will be formed. Now, let me take the density here as d1. Then I can say density of d1 is greater than the rho. When something miscible with water is mixed with the water, then the density of the solution, now this is a solution, no? Now density of pure water is rho, density of solution is higher than the density of pure water. So, let me take this. If you note it down, person note it down. That's an important point that you should know, that that concept should be in that trick should be in your mind to solve the question. Now to solve this question, you should know that. Now river water and sea water. Sea water, river water. Sea and river. In sea, what's the water? Sea water. Salty water. In river, it's pure water, no? It's pure water. So let me take density of salty water as rho s, density of pure water as rho. It is obvious that density of salt water is greater than the density of pure water. So when a ship is sailing, what is the forces acting on it? The downward weight will be acting. Downward weight will be acting as it is floating in the water. There will be an upthrust force will be acting. Weight will remain constant now. When moving from sea to river, the same ship is moving. Same ship is moving. Weight is W. Weight is W. Let me take U here as U1, here as U2. Here upthrust as U1 and here upthrust as U2. You know, upthrust is equal to V rho G, right? When density reduces, upthrust will reduce. When density increases, upthrust will increase. So the ship is moving from the sea to river. When ship is moving from sea to river, what will happen? From low density to high density. Sorry, from higher density to lower density. From high density to low density. In seawater, density is higher. No? When density is higher, the upthrust force is higher, then the volume of ship into the water is less. No? Now the volume, the upthrust force is more. The upthrust U1 is greater than W. Upthrust force is, now I can say here U1 is greater than U2. No? U1 greater than U2 because density of salty water is greater than density of river. Density of water in the river. If density of seawater is greater than river water, then the upthrust U1 is greater than upthrust U2. Okay. Here, upward force is greater, then the object will sink less. When it moves to the river, upthrust force is less, then the ship will sink more. This is the scenario. This is the physics. This is the science. Not it. I have given a detailed explanation. Okay. Now, 28th one, second one. A balloon filled with helium gas moving upward through air. Balloon filled with helium gas moving upward through air. Archimedes principle. A balloon filled with helium gas moving upward through air. Yes. Here, clean this. Now clean this. Now, in the atmosphere, now there will be a weight W. Now. Like in water, there will be an upthrust in the atmosphere to this balloon. Now, if an object is fully or partially submerged in water, there will be weight in the downward direction, upthrust in the upward direction. Likewise, when something is present in the atmosphere, mainly when it now The balloon is filled with air. No? This air is very, very lightweight. It has a low weight is there. Therefore, upthrust is greater than W. Upthrust. Now, upthrust will be acting on an object placed in the atmosphere. No? Upthrust will be acting. That is, U will be acting. Let me take this as U. Because the weight is very, 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 very small, upthrust is greater than W. When upthrust greater than W, what will happen? The helium filled gas will move up through the air. This is what is happening. Therefore, second is also done. Third one, floating of a sunk orange seeds in a glass of orange juice when dissolving sugar. Floating of a sunk orange seeds in a glass of orange juice when dissolving sugar. When sugar is dissolved, what will happen? Density will increase. If density increases, upthrust will increase. Then what will happen? Upward force is greater than the downward force. When upward force greater than the downward force, what will happen? The seed that is sunken will be moving to the top surface of the liquid, will be moving to the upper surface of the liquid. That is, the sunken seeds will now be floating. Why is that? Because after addition of sugar, density of the solution will increase. Therefore, yeah, answer should be fourth. 2021 is also done. There is so much to learn from this question. In the previous question which I discussed with that, this thing, the density and the object like this, there are also something to learn in. Remember all these points. The same pattern will be repeated in the next past paper also. Two 2021 done. Now 2022. 2022. 35th question.
சந்தோஷமா புகழ்றேன் ரைட் ஸ்டேட்டஸ் போடுறேன் அதே ஒரு முன்னூட்டு கார்ல ஒரு வாகனம் வாங்கின பிள்ளைகள் அங்க அடுத்த கடன் தேடுறோம்
2022. 2022, 35th question. Yeah. The water barometer, the vertical height of water column is 10 meter. What is the atmospheric pressure at that instant? Density of water is 1000 kilogram meter cube. Acceleration due to gravity is 10 meter per second minus 2. Now, barometer is something like this, no? Now, they didn't say mercury barometer. They said water barometer. If mercury barometer means here there will be mercury. Here there will be mercury. But it's not mercury barometer. They said water barometer. So now it is filled with water. So what will happen? In this water barometer, the water will rise up to a certain height. And here atmospheric pressure will be active. PATM, PATM. Vertical height of water column is 10 meter. 10 meter. 10 meter. And density of water. Let me take this as rho W. Density of water is 1000 kilogram meter cube. And acceleration due to gravity is 10 meter per second minus 2. Pressure at same level is equal. Now here, let me take this level. Here, atmospheric pressure is at. So here, what is the pressure acting? It is also atmospheric pressure. Here, atmospheric pressure will be acting. If here PATM, then here also PATM. Now let me take the pressure at this point as P1. P1. Pressure at same level is equal. Therefore, P1 is equal to PATM. P1 is equal to PATM. Okay. Therefore, PATM is equal to, what is this P1? P1 is H rho G. What is this H? H is 10 meter. Density is 1000 kilogram meter minus 3 into 10 meter per second minus 2. So 10 into 10 to the power 4 Pascal 1 Newton meter minus 2. No, there is no any, but 10 into 10 to the power 4 is not there. 1 into 10 to the power 5 Pascal is there. Therefore, what should be the answer? 35th one, answer 4th. 1 into 10 to the power 5. Sorry. 35th done. 2022 is also done. Now the last past paper, 2023, 26th question. 2023, 26th question. Fine. If an object made up of a solid substance is to float in a liquid, density of a solid substance should be less than the density of the liquid. The mass of the solid object should be equal to the mass of the liquid displaced. The weight of the solid object should be equal to weight of the liquid volume displaced by 8. Weight of the solid object should be equal to weight of the liquid volume displaced by 8. Weight of the solid object should be weight of the solid object should be less than the upthrust acting on it. If an object made of a solid substance is to float in a liquid, is to float, fully submerged or partially submerged, no, it's not same, is to float in a liquid. Density of the solid substance should be less than the density of the liquid. The mass of the solid substance should be equal to mass of the liquid displaced. Weight of the solid substance should be equal to weight of the liquid volume displaced by it. And weight of solid should be less than the upthrust acting on it. Now, 26th. 1, 2, 3. Without checking 1, 2, 3, let's go to fourth one. Fourth statement. What does they say? Now, here we have an object that is floating. There is W. There is a thrust. Weight of the solid object should be less than the upthrust. Now they say floating, it can fully submerged, partially submerged, or fully submerged. Yeah, if it is partially submerged. Partially submerged means what? As I said you in the earlier question, if it is partially submerged means upthrust greater than W. If something is floating, always remember, if something is floating, when something is partially floating, its density is less than the density of the liquid. Now, when you take this ice cube and if you put into the water, what will happen? The ice cube will be floating on the surface, right? Partially submerged and it will be floating. Therefore, you can say density of, if something is floating, partially submerged and floating, then the density of that object should be less than the density of the liquid. Remember it. Now, when I apply a sand, when I put a sand into this water, the sand will reach the bottom of the container. Why is that? Because the density of the sand is greater than the density of the liquid. If we put ice cube, it will be floating. It will be partially submerged and floating. Then the density of the ice cube is less than the density of the liquid. But when I put stone, stone will reach the bottom. Why is that? Because the density of the stone is greater than the density of the liquid. Okay. Therefore, I can say, now let me take density of object as rho and density of liquid as rho L. Therefore, I can say rho L is greater than rho. Density of liquid is greater than density of object. That is rho I have taken. Now, let me take the second scenario. When something is floating, it is fully submerged. If fully submerged, then what I can say about the upthrust and the weight. Upthrust is equal to weight. And what can I say about the density? As I said you in the earlier question. Density. Now this density is rho L. Let me take this density as rho 1. So I can say rho 1 is equal to rho L. If something is partially submerged and floating, density of the object should be less than the density of the liquid. When something is fully submerged and floating, density of that object should be equal to density of the liquid. And when something is partially submerged and floating, upthrust greater than the weight. Something is fully submerged and floating, upthrust is equal to weight. With that, we'll come to this question. Density of the solid substance should be less than the density of the liquid. No, it's wrong. Why is that? Then they have said density of the liquid should be less than the density of the liquid. They say it's floating. I don't know whether it's partially or fully. If it is partially means density of liquid less than density of object is less than the density of liquid. That means density of liquid is greater than the density of the object. Then I can say that statement is correct. But when I consider this part, when it is fully submerged, then the density of the liquid should be equal to density of the object. Therefore, when considering partially submerged instance, the statement is correct. But when considering the fully submerged instance, then the statement is wrong. Second one, the mass of the solid object should be equal to mass of the liquid displaced. We'll come to it later. Look at the third one. Weight of the solid object should be equal to weight of the liquid volume displaced by it. Weight of the solid object should be equal to weight of the liquid volume displaced by it. See the fourth one. Weight of the solid object should be less than the upthrust acting on it. Weight of the solid object should be less than the upthrust acting on it. No, it's wrong. They said weight of the solid object is less than the upthrust acting on it. W is less than U. U is greater than W. Density of solid substance should be less than the density of the liquid. Mm. We'll check and tell you that question. 2023-26. Forget this, I will check and tell you. Okay, I will tell you this explanation for this question in the next class, and then we move to the next part.